Hey mathematicians, here are your notes for 3.3, solving equations using multiplication and division. Before we get started, let's jump into that bell work. What is our goal when solving equations? As in, yesterday, when we were working on this, what was our ultimate goal for a problem like 4m equals 16? I guess yesterday we were working with addition or subtraction, but the goal remains the same. We were trying to get the variable alone. You'll also hear me call it isolating the variable. So quick challenge, what is the coefficient in front of the variable after an equation has been solved? So yesterday when we had a solution that said x equals 3, what was that coefficient, or what was that number in front of x? Another way of thinking about this is, what number was x being multiplied by? Even though it's not there, there was technically a 1. 1x equals 3. Today we're going to start working with coefficients that are not 1. So we'll have a problem that looks like the one I gave you up here, 4m equals 16, and we need to be able to solve this and get m alone without that coefficient in front. So today's goal is to be able to solve a one-step equation using multiplication or division. Let's consider a real-life problem first. In a race, Abigail starts getting tired after running 6 miles, which is 3/4 of the total distance. What is the length of the race? Well, if we look at the race like this is the total race, and she got tired at 3/4 of the race, which we know is also 6 miles. We need to know what each quarter of the race, what that distance is, so that we can say what the total length is. Well, if we know this is 3/4 and she ran 3 sections before, each of those sections is the same length. So we can split that 6 miles up into 3 different lengths, meaning that each quarter of the race is going to be 2 miles. This is 2 miles, this is 2 miles, and this is 2 miles. Because we know that they're all the same distance as well, that means our last jump is also going to be 2 miles. So if we look at this visually, the length of the race is that 6 miles plus that final 2, and the total length of the race is going to be 8 miles. Now again, this was a pretty easy problem to kind of visualize and work out using common sense. However, they're not always going to be. So let's start looking at some different problems so that we're ready when the problems get more challenging. Let's look at these first 3. What divided by 5 is equal to 1? In this case, we know 5 divided by 5 is equal to 1. Any number divided by itself is 1. What times 2/7 is equal to 1? That one's a little harder, but the answer in this case is 7/2 because we've inverted that 2/7. I can prove this because 7 times 2 is 14, and 2 times 7 is 14, meaning we have 14 divided by 14 equaling 1. That one is a little tricky. This last one is very similar. How do we get this to be something divided by itself to equal 1? Well, if we have something divided by 6 on the bottom, that means that whatever is on top must multiply to 1 in order to be 6. So 6 times 1 is 6, divided by 6 is 1. And in order to have something on the bottom, we're just going to invert it and say it's 1. However, this one's a little tricky. 6 times -1/6 is -1. So if we want to undo that negative, we have to put a negative sign in front of our number. So now we have -6 times 1, which is -6, over 1 times 6. So therefore, -6 divided by -6 is 1. So we already did the first one. What number must go in each of the above boxes to make the equation true? But how do we undo multiplication? Well, we can either divide the number by itself, or we can multiply by the reciprocal, which is just what we do when we put the numerator in the denominator position and the denominator in the numerator position. How do we undo division then? By multiplying by that number. Multiply by the reciprocal. Same thing. So if I want to undo 1/6, I need to multiply by 6, or in this case 6 over 1. They're interchangeable, so it doesn't matter. So if I look at the bottom here, consider these examples below. How are you going to solve or isolate each variable? Well, I do this by first looking and saying, here's my variable. It's currently being divided by 30. Just as we set up here, how do we undo division? We have to multiply. Right now it's 1 over 30, so I need to multiply by 30 over 1, or just 30. This is divided by 30. I'm now multiplying by 30. That cancels those out, and I'm left with t on the left side. However, as I've been saying again and again, whatever you do to the left side, you must also do to the right. We have to keep it balanced. 10 times 30 is 300. Notice we have our variable isolated, so we're going to box it. The next one, we have 1/4 x equals negative 3/8. This is multiplication, so we could divide this by 1/4 and then divide negative 3/8 by 1/4, but that is a lot of fractions that I don't want to deal with. So in this case, I would rather multiply by the reciprocal. So instead of dividing, I'm just going to multiply by the upside down version. Why does that work? Well, 4 times 1 is 4, 1 times 4 is 4, 4 divided by 4 is 1, leaving me with just 1x on the left side. That allowed me to isolate my variable because now I can get rid of that 1 and it doesn't change the problem. But whatever I do to one side, I have to do to the other. So 1x is going to equal negative 3 times 4 is negative 12 on top, 8 times 1 is 8 on bottom. Of course, this isn't how I'm going to leave my answer because it's not simplified. I'm going to get rid of that 1 to start off with, and then I'm going to reduce this. Negative 12 over 8 becomes negative 6 over 4, or negative 3 over 2. Now that I have my variable isolated, I box it and move on. The next one, it's a little tricky, but it's okay. I've got 2 1/4 g equal to 3/2. Now, I'm not really used to dividing with mixed numbers, so in order to make this problem easier on myself, I'm going to change this to an improper fraction. 2 times 4 is 8, 8 plus 1 is 9. So this is the same thing as 9/4 g equal to 3/2. Now that I have this nice fraction, I'm going to multiply by that reciprocal just as I did in the last problem. I'm going to do it on both sides here. And as I said before, 4 divided by 4 is 1, 9 divided by 9 is 1, and that cancels, leaving us with an isolated variable on the left, and 6 over 9. This would actually be 12 over 18, or 6 over 9, or 2 over 3. That took me a minute. That's okay. 2/3. Variable is isolated. I'm good to go. Notice I've got multiplication by 8 happening in this next one. Can't leave that alone because that means that that n is not isolated. It is not by itself. Therefore, this is not a simplified answer. So instead of leaving it, we're going to divide by 8. That gives me a 1 in front of the n. But whatever you do to one side, you have to do to the other. 64 divided by 8 is 8. Now this is isolated, so I box. Alright, last one on this page. Negative 5n equals 60. Because this is currently being multiplied by negative 5, in order to isolate, I need to divide by negative 5. These cancel. I'm left with 1n. On the right side, I need to divide. 60 divided by -5 is -12. It is isolated, so I'm done. Let's hop to the back then. I would like you to pause the video here, try this challenge on your own, see if you can get the answer, and then come on back and we'll do it together. All right, hopefully you had time to try the challenge on your own. The challenge says, if 4m equals 12, what is the value of 5m? Well, I can't figure out 5m if I don't know what m is equal to. So let's go back to our original problem and see if we can solve for m. I notice m is being multiplied by 4, so in order to isolate the variable, I'm going to divide by 4. Whatever I do to one side, I do to the other, and I get m isolated is equal to 3. Now that I know this, now that I have m equals 3, what I can do is I can come over to my 5m that I don't know what it's equal to, and I can plug that variable in. I can say instead of 5 times m, I can rewrite this as 5 times 3. The same way if I take the m out, I put the 3 in. They're equal, so mathematically I am allowed to do this. Now I can simplify and say 5m is equal to whatever 5 times 3 is. In this case, 15. I can even go a step further. I can check that answer and say, if I know that 5m equals 15, and I know that m equals 3, when I solve this problem, I should get m equals 3 as my final answer. Let's do the middle step. If this is multiplied by 5, I need to divide by 5. Divide by 5 on the right side. And when I do this, I do get m equals 3. This is one of those problems I was talking about yesterday where I said the original answer might not be of much use to us, but we may be able to use it to solve other problems. So be prepared for more of these challenges coming up. Go ahead and work on your practice, and if you have any questions, let me know.